military aircraft with the letters SU on the side have been protecting the airspace of our motherland for more than 7 decades now. Sukhoi company designers passed on their talent to the warplanes they created. This talent is the skill to be able to select precisely the right target.
Когда речь идет о безопасности страны,
when it's about national security and defense of the state, the price of an error might prove too high. Of course, this holds true for the defense industry and military science in the first place. In industry as in science, it's important to follow time-tested traditions. A school is the guardian of these traditions. A distinctive feature of aircraft designer Pavel Sukhoi is that his design bureau has always tried to make shortcuts and to be the frontrunner. It was the company policy as it designed planes for pilots called Stalin's Falcons, and now as it makes the T-50 advanced aircraft flight-worthy. The T-50 is a fifth-generation military aircraft. Yet any plane developed by Sukhoi, even this warplane of the future, is intended for ordinary fleet pilots, not just for aces. The key criterion in trials, with test pilots demanding, requesting, persuading and even begging, is that the plane be such as to enable a person of sound mind, an ordinary pilot, so to speak, to easily accomplish absolutely any mission in most adverse combat conditions. As I was descending, my variometer began to give odd readings. I want to say that the Americans have the F-22 and the F-35. We didn't retrace the path of emulating one of these projects, trying to create a balanced system instead, which would secure superiority over potential rivals. T-50 chief designer Alexander Davydenko believes that the plane has integrated the best Sukhoi company achievements.
в развитии любой техники,
in developing any equipment, especially military hardware, there always comes the important stage when it's necessary to make a spurt in order to achieve something entirely new. Otherwise, your rivals catch up and trample you underfoot before you know where you are. The T-50 has become the first Sukhoi warplane featuring complete digital design. Production of equipment in the modern world is not possible without using computer-aided design or creating a digital mock-up. In working with digital mock-ups, Sukhoi company designers also use supercomputers created at the Sarov-based Federal Nuclear Center. Today we have an opportunity to simulate the behavior of real systems in real operating conditions, which enables us to predict the behavior of the plane. It demonstrates the effectiveness of a digital mock-up. Left screen shows a digital mock-up of a plane. Right screen shows it in a flight test. This video is to show that a large part can be modeled even before a plane is produced as hardware. Our work can be as fascinating as a game. As digital design was introduced, all young designers claimed that computer-aided engineering was much more interesting than drawing. Sukhoi company has an original system to attract young people. This helps it maintain top performance level, despite the natural change of generations. There are many young people both in the design bureau and on assembly line. This is the Yuri Gagarin aircraft plant in Komsomolsk-on-Amur. Not show the T-50 assembly shop because it's a top secret plant. However, the T-50 has integrated much of what was used in developing the Su-35, which is assembled in this shop.
А вошел в ваш район, прошу снижения. до верхней кромки облачности по вашему посадочному.
Каждый инженер, каждый...
Today, every engineer, technologist, policymaker and production foreman is integrated in the company system. They have a good grasp of digital mock-ups. The Soviet Union production began at restricted access experimental companies, and later a package of technical documents on the aircraft was passed to a production facility. Work them to match its manufacturing capabilities. Batch production technologists, together with production designers, would take up the project and in a very critical approach would mold it into available technological forms. At the present time, prototypes are manufactured at a batch production enterprise from the beginning to account for existing technologies. Even as we were developing the fifth generation plane, we implemented the so-called single startup procedure. We forwarded a package of documents in electronic form to the manufacturer and simultaneously completed nearly all technological preparations. It was a consolidated effort of the production plant technologists and the Sukhoi Design Bureau specialists. As soon as we had accomplished it, we had to consolidate all this into one company. We were no longer merely a design bureau. We lived one life with the production facility. It's a synergetic effect from merging into one company. Price optimization alone saved us millions of dollars. An earlier government policy was to order chief designer to build such and such plane, never mind the cost. At present, Sukhoi company cannot afford it. Otherwise, it might face bankruptcy. With a permanent austerity budget, any government will only finance realistic projects, not just beautiful, modern or fashionable ones, but realistic projects, meeting the cost-quality principle. Sukhoi company is just a firm offering cost and quality effective projects, and it delivers quickly. Least number of flight tests, maximum workload on the ground. Taking off. Thanks to this approach, the T-50 was developed in just 8 years, a short time for the aircraft industry. The T-50 development involves a tremendous number of test benches. All the work runs on test benches, and flight tests only deal with what was confirmed by bench test results. Designers have been working jointly with test pilots almost from the beginning of the project to develop the new aircraft. Pilots are directly involved in the development of new planes. I recall a line from Vladimir Vysotsky's song, "I've known you since I saw your schematics." Of course you know the plane, yet it's only a flight simulator that lets you see how the plane can fly. Ready for takeoff. It's the designers of military aircraft who are the first to start its virtual flight. The Su-35 is the first multi-role single-pilot jet. Enabling one person to combine the function of pilot and operator is a quite difficult task. It requires a thorough drill of the logic of interaction between the man and the machine. Pilot's influence is tremendous, because many things are about ergonomics and man-machine interaction. You want to meet pilots' concrete requests. Setting a course for combat mission. Engineers and pilots differ greatly in their views, and what seems convenient and well executed to the engineer might in fact cause problems for the pilot. For more than 2 hours, you experience constant G-forces and unnatural spins. It tires you to the point when you need to briefly switch over to pure oxygen in order to recover yourself. Test bench brings together parts of avionics manufactured at different companies. Have to interact for the first time. It's the designer's job to have them function together as one whole.
Мы можем в день провести
We can run dozens of simulations a day and launch as many targets as we need.
проверку
We
сложности.
can check out the complex modes which can hardly be done in real flight, simply because they are too dangerous.
Что-то я теряю высоту.
I'm losing altitude. Slightly, of course. Okay, I'll try to capture the glide slope. I have to gain altitude.
Ну,
I just lost track simply. I lost. Modern combat sets high requirements both for the pilot and the plane. Tasks the pilots have to perform today are far more complex compared with what they had to do only recently. Whereas a plane could fire some 5 different types of missiles before, the present-day range of armaments reaches 42. Furthermore, they have to be fired simultaneously to engage different targets.
вот сейчас я под глиссадой
Now
иду.
I'm flying the glide slope too fast. 200 meters isn't good for landing.
Так мы...
Will collapse the struts if I go on. But then I'm not a pilot. It's a computer game, in a matter of speaking, but the difference is that it runs on real aircraft equipment. A tradition to minimize the number of flight tests in order not to risk the pilots' lives dates back to Pavel Sukhoi's leadership. Pavel Sukhoi's style of designing warplanes always stood out, came known as Sukhoi's style. It envisioned a maximum of new solutions and a minimum of risks. In other words, it was sound technical conservatism. Sukhoi's surname, which means dry, was a very fitting description of that man. He wasn't the smiling or talkative type, yet he was the hub of intelligentsia, most positive sense of the word. It's in reference to Russian intellectuals. I recall Pavel Sukhoi's phrase, "If a staff meeting lasts more than 20 minutes, it means it was poorly prepared." He made the decisions that proved to be visionary, with a far-reaching effect. It was a vision. Pavel Sukhoi and the team he created had a unique talent. They were equally successful in developing different types of aircraft, intended for various missions, such as fighters, attack aircraft and bombers. It was a distinctive feature of the Sukhoi school.
Сухого всегда отличала новизна.
Novelties always set Sukhoi apart. Every project was cutting edge if you looked into it. Like Winston Churchill's phrase about doing today what other people will think of doing tomorrow. This is what we can do. It seems we can do it. This would explain in no small measure the fact that 60% of all Russian warplanes currently in service feature the letters SU on the side. In designer's work, it can so happen that an uncompleted project yields a far greater effect than an aircraft finalized for batch production. Much of state-of-the-art technology for military aircraft was developed during the work on the T-4 strategic bomber.
И в этой истории
In this project, Pavel Sukhoi had to compete with the very influential Andrei Tupolev, whom he regarded by right as his teacher. In the late 1950s, aircraft carrier groups became the main strike force of the US Navy. Russia needed a supersonic strategic missile-carrying bomber to counteract them. The military badly needed an aircraft, and Pavel Sukhoi outlined the project of such a plane, which basically met the military's requirements at that time. Pavel Sukhoi was a student of the great Andrei Tupolev. It was Sukhoi's team that built Tupolev's legendary AN-T-25, which Valery Chkalov's crew flew across the North Pole to America. Now, Sukhoi entered a tough competition with his teacher for a missile-carrying bomber project. Making a long-range supersonic bomber wasn't in our line of work absolutely.
Андрей Николаевич Туполев позвонил.
Andrei Tupolev phoned Pavel Sukhoi saying, "This plane in terms of size isn't your department. You make good fighters, but you can't handle this one." Pavel Sukhoi replied thus, "Dear Andrei Nikolaevich, you are my teacher. I hope that as your student, I'm not bad. So I'll cope with this task.
И
Tupolev, who'd been playing by the same rules offering his version of the bomber, found himself at a loose end. Bomber was codenamed T-4, but design bureau insiders called it Sotka, meaning 100. The official name reflected an expected takeoff mass of some 100 tons. Eventually, the mass actually reached 120 tons, but the name stuck. Aviation statistics show that a new plane's novelty coefficient does not normally exceed 30%. For the T-4, made up a staggering 95%. During the T-4 development, some 600 inventions were made and implemented. It required new pressure, drives, and technologies. Titanium welding was done for the first time in our aircraft making. After the T-4 or Sotka made 10 successful test flights, the project was unexpectedly closed. Of course, it was frustrating. Perhaps not just frustrating. It was a great injustice. Fate of the famous designer Pavel Sukhoi is an unbroken line of paradoxes. For example, he was chief designer of a leading design bureau of the Soviet Union, and yet he was not a Communist Party member, which seemed odd at the time. He was awarded Stalin prizes for designing aircraft, yet his planes were not put in batch production for some reason. He sort of stayed in the shadow of his more famous colleagues, Mikoyan, Tupolev, Yakovlev. Unlike them, he was not on good terms with government officials. But when the time of new speeds, the time of supersonic speed had come, it was the Su planes that took the niche, making the backbone of frontline aviation. The G4 used the so-called fly-by-wire system for the first time in our country. Today, it's the key control component of any plane. Cable routings through which commands from the cockpit are transmitted have multiple backup. Reliability is among the key features of Sukhoi planes. I am disconnecting the first coupler to simulate initial failure. As you see, the drive is continuing to work. Disconnecting the second, and again, it's still working. As I disconnect the third, it is working still as it should. It's only after disconnecting the fourth coupler that the drive should stop functioning and slide back. We're going to see it now. Disconnecting now, and indeed, it has slid back. 4 successive failures would be an impossible occurrence. The routings are at the maximum separation distance, running through different plane sections. Damage to all of them is not possible even in heavy fighting. Plane operation is impeded. Of course, handling a plane in a failure state requires skill. The Le Bourget International Air Show. Regrettably, the weather was very bad, with low clouds, rain and a possible thunderstorm. Emergency occurred during a demonstration flight. As I began performing a loop, a lightning struck the plane when it was at the highest point, burning nearly all avionics. Instinctively, I grabbed the ejection seat's handles, and the first thought was to pull. As I put my hand on the control column and gave it a try, I saw that the plane responded, so I assumed it was too early to eject. I pulled it out of the aerobatic maneuver, approached to land, and put it down using pressure instruments only. fly-by-wire system for the T-4 was developed, designers and pilots were very concerned about possible failure, as the system had never been tried before in the history of aircraft making. Such breakthrough projects as Sotka form a new intellectual and technological level of the design bureau, a new intellectual and technological level of the industry. I think it became good groundwork for making a plane of an entirely new class on the basis of the developed technologies, a multi-role fighter. Su-27 was developed as a heavy class fighter with a primary objective to gain air superiority. If necessary, it could be strategic bomber's escort on long-range missions. When the Su-27 appeared over the North Pole as bomber escort for the first time, it impressed the world greatly, because no such thing had ever happened before. This plane had to become our response to the US fourth-generation fighter F-15 Eagle. But when batch production of the new Su plane began, it became evident that it was inferior to the US counterpart. Clearly, some performance characteristics, though fully acceptable to the military, not met the targets. Mikhail Simonov was appointed chief designer of the Su-27 in February 1976. It was up to him to decide what to do with the new plane. He had to convince the Soviet Minister of Aviation Industry that a drastic revision of the project was crucial. I should say that within a very short time frame, a plane was created, which was in fact absolutely new.
Выполняет 32 тысяч. Выводим.
In setting performance targets for a new plane, designers always make it 20% better than its predecessor. But this plane was 100% new. The plane was a great success. The Soviet aircraft making found itself in a difficult situation in the 1990s. It was the Su-27 that helped its designers.
Этот самолет было запрещено.
This plane was under the export ban. When our Air Force stopped placing orders for new planes in the 1990s, the question was quite simple. Will the design bureau keep afloat or not? The very aircraft production in Russia was under threat, and again, I recall the significance of Mikhail Simonov. Mikhail Simonov was chief designer of the company at the time. He had to rely on himself in seeking access to international markets of military aircraft. He suggested finding ways to export these aircraft as the only opportunity to keep afloat. We had goods for sale, excellent goods, and the world was interested in them. But the reaction went as far as accusing us of selling our motherland. Mikhail Simonov argued that we were not selling the motherland, but saving its aircraft making. Eventually, he was able to contact President Yeltsin and explain the situation. He understood our cause and okayed the sale of the first batch of warplanes. The contract to supply the Su-27s to the Chinese was in fact a bailout for our company. Not just that, it saved other firms that had helped to develop this plane.
Компания Сухой.
Sukhoi company did not squander money. It did not just spend it. I believe it made competent and reasonable investment in the production and development of new planes.
Знаменитый индийский контракт.
The famous Indian contract that followed the one with China was fully new, both in the way of technicalities and organization.
Мы заключили контракт.
We signed a contract with a friendly India for a plane that did not exist yet. There was a prototype, the Su-30 plane, and it was a starting point for our negotiations. In an unexpected outcome of the 18-month talks, Russia offered the Indians an entirely new warplane, which had yet to be designed. A plane based on an existing prototype nevertheless differed greatly from it, having enhanced effectiveness, combat capability and intellectual capacity. Russia had no such contracts with foreign partners before. Su-30 MKI became the first batch-produced warplane in the world, featuring thrust vector control, which afforded super maneuverability. Simonov said that having kept the design bureau afloat will create new planes. All these ideas and his thoughts have come alive today. Export contracts enabled Sukhoi company to make a mighty leap forward, to lead the way to initial supplies of new equipment to the Russian Air Force in subsequent years. Presently, deliveries of Su-30SM multi-role fighters to the Russian Air Force are in full swing. Fleet pilots say that the combat capability of this aircraft has been enhanced by several times over that of older planes, which have been in service. In addition, the fighter's super maneuverability opened up new era in piloting. Dmitry Rogozin was lucky to fly on this new Russian warplane. It's not the export version of an Su plane. The fighter is fully adapted to the requirements of the Russian Air Force. It's a unique plane that can do any aerobatics. It responds not just to pilot's hand-on controls. It obeys his thoughts. With modern avionics and available armaments, it's a formidable warplane, capable of gaining not merely air superiority. Appearance in the air arouses fear in any enemy. Su-30SM is not just a modification, it's a step forward towards creating a new generation of Su plane. Over 3 decades, Sukhoi company created a unique family of aircraft based on the Su-27. The Su-33 deck fighter, Su-30 Mk two-seater, and its numerous export versions. The super maneuverable multi-role Su-35, Su-34 tactical bomber, As for the Su-34, it's a unique program. No counterparts in the newest history. The plane was built with such performance characteristics that today it's unique in Russia and elsewhere. It will be batch produced for the next decade or so, or even 2 decades. In fact, it's a higher class plane. Its next generation encouraging a further step in the field of warplane design, production and exports. The Su-27 platform and numerous modifications secured Sukhoi's lead over the years. In the long run, the success of aircraft makers relies on the product they produce and export. Today, the T-50, also known as Advanced Frontline Aircraft System, is top of Sukhoi's product line. In making any sophisticated equipment, errors are inevitable. Reliable checkout system guaranteeing flight safety is key. These errors are checked out from the very beginning till the end of service life, guarantee fault-free performance throughout all operating life. Due maintenance and repairs. In order to secure fault-free operation, we have to do 30,000 cycles. Every 7,500 cycles, we remove and disassemble components and inspect them together with the designer, the manufacturer for wear and tear, placing the bad parts. The number of these cycles should exceed that of a real plane by 5 times. In other words, the landing gear is given a 5-fold margin of safety. Things are quite different with the airframe, because it does not require such safety margin. This is a static test shop, which is number 1 test bench. It has top priority as it clears the plane for flight. This means that the test results are crucial for the plane to take off. It's a sort of the final checkout of the designer's solutions, manufacturing methods and production assembly. This is the T-50 plane. This is the way it looks in the static test shop. Studded with sensors. Thanks tests, the stress load put on the plane matches the actual in-flight stress. Beginning the test. 10%. An ideal test is where the plane withstands a 100% stress load. 30%, 40%. If it withstands less than 100%, it means its strength is insufficient. 70%, 80%. If it withstands much more than 100%, it means the plane's strength is sufficient, but that it's overweight, so it's possible to reduce its mass. 100%. That's it. This plane part has passed the test. It won't let down in a fight. Sukhoi warplanes not only have been protecting the borders of the country, have proved themselves very well in military conflicts of the recent decade. That's why almost 40 countries imported Su planes, while in some states they make up the backbone of their air force. The Su-7B was the first fighter bomber produced by Sukhoi Design Bureau. The Su-7 was initially designed as a frontline fighter, later developed as a fighter bomber. The whole family of Su-7B aircraft was developed along this line, that is by enhancing the combat qualities of the fighter bomber. The plane was the main attack aircraft of our frontline aviation for a long time, and it was appreciated abroad as well. By the time the Indo-Pakistani War had broken out in December 1971, the Su-7B was the bedrock of the offensive power of the Indian Air Force. The Indians praised the performance of the Su-7B in the Indo-Pakistani conflict. It had a rather powerful combat load at 2 tons and a high tolerance, meaning that many aircraft, though seriously damaged, were finally able to return to the airfield. It's the legendary Su-25 attack aircraft that happened to do most of the fighting. As the designer said, it was a flying Kalashnikov rifle, simple, convenient and reliable. Su-25 performed particularly well in Afghanistan. In the so-called Farah operation on the eve of May 9, 1980, Soviet land troops tried to enter a gorge accommodating weapon depots and food stores. The infantry met with tough resistance. 8 500-kilogram penetration bombs were loaded on a Su-25 to engage reinforced concrete bunkers installed at each turn of the gorge. The second plane, meant to engage manpower, carried 32 100-kilogram bombs. Our planes flew sorties for 2 days, not more. And then Soviet troops came through, entering the gorge without firing a single shot. Today, a combat test for a plane remains crucial in its selection by foreign customers. Our Indian customers found another trial formula for our plane, involving them in joint exercises with the Americans. The outcome of these airfights confirmed the effectiveness of our aircraft. This means that even such unorthodox forms of comparison of warplane confirm the effectiveness of Sukhoi developments. Designing a plane is just part of the job. It's also important to make it fly. At present, Sukhoi company runs the most powerful and productive testing center of Russia's aircraft industry. Any complaints? No complaints. Ready to fly. Pilots of the Sukhoi flight test and development base fly 1,500 sorties a year. This is exactly where all new Sukhoi planes are tested, including the T-50. It's an altitude compensating suit.
В случае разгерметизации самолета
Its acronym is VKK-15.
происходит разгерметизация. Соответственно,
It's used in case the plane depressurizes at high altitudes. If it happens, pressure air is supplied through these expandable pipes and hoses to prevent blood vessels from bursting,
под давлением.
inflating the suit and squeezing the pilot's body under pressure, thus protecting his blood vessels from damage. In emergency, it gives enough time to the pilot to descend to a safer altitude. It might come handy once in the lifetime only, yet it will be a life-saving chance. If you want to display a plane to advantage at the max airship, you have to load it well, and you can experience G-forces up to 9. It happens quite often. As we were simulating an air fight, a foreign pilot turned his head, damaging his backbone because of accelerating force. Though it was just 5 G-force, out of commission. A 9 G-force is more powerful. Consider, if a person weighs 80 kilograms, a 9 G-force increases his mass to 720 kilograms. There is compulsory recording of all flight data of any flight, which is later analyzed. These hard drives store information on 15,000 parameters. No flight test is like the other. Each has to bring something new. What good is going over the same thing again? Nevertheless, the targets evaluated in a previous flight reveal some shortcomings or faults, so they are re-evaluated for statistics. Any aircraft has 2 such data storages, each with a 40 gigabyte capacity. The data storages are necessarily Russian-made and very reliable. It's a unique thing. Most importantly, it's built solid. That is, it has no connector cables. It has a normal port. There's just one way you can insert it. You can drop it into water or hit it. That is all made Russian style, which is very right. To complete any challenging flight, a test pilot must do a hang on a horizontal bar, an exercise obligatory for all. Demonstration of high maneuverability in flight, stress for the backbone. The space between intervertebral discs shrinks, so I believe it does good to do a hang after a flight, in order to stretch out the backbone a bit. Sukhoi company decided to work in civil aviation in the early 2000s, doubted that it would be successful. Technologies tried out in developing warplanes are used in designing civil aircraft. Soviet Union, it was a policy of almost all leading aircraft makers. The Tupolev, Ilyushin and Yakovlev manufacturers designed both military aircraft and civil planes, all but Sukhoi did. In the early 1990s, government procurements of military and civil planes nearly stopped in Russia. Airlines preferred to build up their fleets of aircraft with foreign planes, because the domestic industry could not offer competitive products in terms of cost and quality at that time. Sukhoi became the only domestic firm which decided to risk and design a civil plane. This short-range aircraft had to become the best in its class, not only in Russia, but also on the world market. The company risked its hard-earned funds derived from exports of warplanes. They did take the risk and designed the Superjet, which is now competing with major world producers on the commercial aircraft market. Create the Sukhoi Superjet 100. Comprehensive retooling program was implemented in Komsomolsk-on-Amur. In fact, it set up a plant within a plant. Of course, it was a risk, because it was not clear if there would be demand for the plane. The main reason we got into it
Не потерять.
was not to forfeit Russia's civil aviation at that time. Furthermore, the technologies used in developing Sukhoi warplanes help this civil aircraft fly.
Уникальная система управления, которая
It has a unique control system ensuring the highest possible safety level on civil aircraft. It cannot get into a spin. The plane warns about possible critical flight situation. Symbolically, the development of a new generation civil aircraft ran parallel to the T-50 project. The T-50 Advanced Frontline Aircraft System, which is being developed by Sukhoi company, is truly a warplane of the future. It will provide reliable protection of the borders of our country for decades to come. Our country first tried out fifth-generation technologies on this plane. Unusual appearance. It is the Su-47 Berkut. A striking feature in its appearance is its special wing, called a forward-swept wing. Forward-swept wing has certain advantages at high angles of attack from the point of view of lift gain. The problem was that it was difficult to ensure dynamic strength of this original airframe. Solving the problem was possible only by using composites as construction material. Su-47 Berkut was developed in a very difficult economic situation. Early 1980s marked the end of developed socialism and the beginning of restructuring. Funding stopped for whole industries, not mentioning individual experimental design bureaus. Yet, a design office is a fine-tuned mechanism. It cannot work today, idle tomorrow, and start working again the day after tomorrow, not in such constant transition from one mode to another. Designers would not have been able to develop a fifth-generation plane if they had not worked on earlier generation military aircraft. With no funding from the state, Sukhoi Design Bureau developed the Su-47 using its own money. At that time, the company didn't have much money. We were well aware that we needed a certain amount of developments at hand and experimental work to make a basis for the fifth-generation plane, which was our dream. This is how Berkut became an airborne laboratory for our fifth-generation warplane. Su-35 was the next step. It was a 4++ generation aircraft. With the T-50, we already have an opportunity to automate a larger number of modes and tasks. The T-50 has the performance characteristics the Su-35 can never achieve, in terms of stealth capability or secret modes of operation of avionics, which is a special design feature. The advanced plane was developed as a production aircraft from the very beginning. You cannot arrange production if you do not create its groundwork at the designing and testing stage. Thanks to the state armaments program, we can see our production targets for the next decade and even beyond. Our great founders of the Sukhoi firm always said that we should start designing a new plane before completing the previous design. This is what we do now. We should always achieve ambitious goals, presenting new challenges to the company team, and this is in fact the basis. In the summer of 2014, the T-50 fifth-generation plane was delivered to the Russian Air Force for state flight tests. The rule of the Sukhoi school is to precisely select the target. calculate the shortest way to it, take a shortcut, thus gaining time. Even if this target seemed unattainable, he always attained it. Zander Muzhaysky, the designer of the first Russian plane, used to say that he wished to devote all his life to service to his fatherland. This is the secret behind Sukhoi Company's success, that is, to be useful to his fatherland.